for this series we have to find how many terms we have to take so that the sum is within this one to the sum of that of this infinite if this series was infinite. So with the infinite, if the series was infinite, we would get a sum. Here a is 2 and r is half. So the infinite sum would be a over 1 minus r, which is 2 over 1 minus half, that is 4. So we have to make this series a finite series and we have to decide how many terms we will need so that the sum of that finite series is within within this much of the sum of the infinite series. So that sum will be 4 minus 0.00001, so that's 3.999. So now the sum, since this is a finite series in now, so the sum will be a, and since r is less than 1, it will be 1 minus r to the power n minus 1 minus r. So our sum will be in this case 3.999, and we have to find n, how many terms do we need. So 2 here, 1 minus 1 to the power n, and then 1 minus half there. So that's 3.999 over this half and then 4, so that will be 4 there. So 1 minus 1 to the power this much, so to the power n, 1 minus 3.999 over 4, so that one is 0.00025 there. So 2 to the power n can become 1 over 0.00025. So 2 to the power n becomes 4000 now. So we need to solve this for n. So what we should do, we should take e-base logarithm on both sides. So ln e 2 to the power n and log e 4000. So this becomes n log e 2 and then log e 4000. So n becomes log e 4000, and we have to take the nearest integer. So it will be 11 point something, so it becomes 12. So we have to take at least 12 terms so that this is within, the sum is within this range, within this limit of the infinite sum.